This is question 3 from chapter 6, and the topic is calculating wavelength from frequency and calculating the energy of a photon. The question is, what is the wavelength in nanometers of a photon with a frequency of 6.32 times 10 to the 14 inverse seconds? This is blue visible light. What is its energy? Step 1, we're going to identify what we are being asked to find and what's given. So it wants the wavelength in nanometers, and it wants its energy. We're given that the frequency is 6.32 times 10 to the 14 inverse seconds. We're going to use the equation that the speed of light, c, is equal to the wavelength times frequency, and that energy is equal to h, which is Planck's constant, times the frequency. This can also be written as E is equal to Planck's constant, h, times the speed of light, c, divided by the wavelength. Step 2, we're going to use c is equal to wavelength times frequency to find wavelength. So we're going to divide both sides of this equation by frequency to give us wavelength, and the speed of light is equal to 3.00 times 10 to the 8 meters per second. Plugging those values in along with the frequency gives us 4.78 times 10 to the negative 7 meters for our wavelength. Step 3, we're going to convert from meters to nanometers using the conversion that there are 1 times 10 to the 9 nanometers in 1 meter. This gives us 475 nanometers for our wavelength. Step 4, we're going to find the energy using E is equal to Planck's constant times frequency. You can also use this equation here, but I'll be using this one instead. So Planck's constant, which is h, is equal to 6.626 times 10 to the negative 34 joules seconds. So we're plugging that value in along with our frequency and multiplying those two together gives us our energy is equal to 4.19 times 10 to the negative 19 joules. And always remember to check your sig figs.